Hello everyone, welcome to my YouTube channel Nafi's Learning Zone. So this is my first video in class 10 science classes. So today I'm going to start the chemistry. So as you all have learned in 9th standard about atoms, you know that atoms are the tiny particles from which this whole universe is made up of. Everything, each and everything, this mobile phone in which I am recording myself, you, every other object composed of matter. You have studied that matter is anything which occupies space and has a definite mass. So that matter constitutes of tiny particles known as atoms. And these atoms, what you studied in 9th standard, this year what we are going to learn is how do they react with each other, how the matter react with each other. These atoms react by different means. They might be by gaining of electron, by losing of electron, or by sharing of electron. In different modes these atoms react. So in first chapter of 10th standard we are going to learn in what different types do they react and why they react and how they react. The first very important thing, the question is, why do they react? These elements reacts or the atoms reacts to become stable. So probably you have learned in 9th standard about different elements, their valences. So many different elements are there in the periodic table. The elements belonging to first group is having valency 1s, while elements belongs to group 2 having valency 2, so on. Group 3 is having valency 3. The first three periods doesn't have group 3 to 12. So then group 13 is having valency 3, group 14 is having valency 4. Then again it is going to decrease 3, 2, 1. But the last group, 18th group, elements has valency 0. So these elements are called as stable elements or inert gases. Every other element in the periodic table wants to become like them, wants to have an octet state, that is 8 electrons in their outermost shell. So to become that, to be stable, to get 8 electrons in their outermost shell, elements react. So how do they react? Let us see in the chemical reaction takes place everywhere, inside your body, inside the kitchen, inside your room, everywhere the reactions are happening. But we may not come across that how it's happening. But most of the reaction what we perform can be observed by observing some indicators. These are the following indicators which can show us there is a chemical reaction has taken place. So you can see here the change in color. When you mix two or more substances or something which happens, so say something like when a fruit is ripened. Anyways, now there is mango season. Right after we come out of the lockdown, hope we will observe tasty mangoes. So this mango changes its color from green to orange red. That change in color indicates there is a chemical reaction taken place. Not only that, many reaction being indicated by change in color. Same way, you can see the next one from the left, change in odor. I hope you know what is odor. Odor means smell. So what happens generally? Imagine a tasty food is being cooked in your home today. That smell you observe, from the smell you can detect tasty food has been prepared. So that odor indicates there is a chemical reaction which has taken place, due to which that odor is released, right? So the third thing is production of gas or vapor. Sometimes when certain reaction takes place, a gas is evolved in that. So that evolving of gas, suppose for example when you open the cold drink bottle, a gas is liberated, carbon dioxide is liberated there when carbonic acid undergoes decomposition reaction. So that indicates there is a chemical reaction inside that. So same way, when the energy is liberated in the form of heat, light, so that indicates there is a chemical reaction. Suppose for example when you burn methane gas in your LPG cylinder, heat is liberated, which is used for cooking. So that liberation of heat indicates there is a chemical reaction there. The same way, when you burn crackers, it liberates some smoke, it liberates, there is a light formed there as well as sound. So light and sound are formed during the chemical reaction. So that indicates burning of crackers is a chemical reaction. Then, so finally, there is one more point which you have to remember. The generally the chemical reactions are difficult to reverse. Like you might have studied in 7th standard, physical changes and chemical changes. Physical changes are usually reversible. Chemical changes are generally non-reversible or irreversible. How do we represent a chemical reaction? So chemical reaction is represented by using two things generally. You can see on this slide there are reactants and products. At the left hand side we usually write reactants, and at the right hand side we write products. So you can see this is a simple reaction which you can perform today inside your home, which will actually create a very nice thing. So generally you might be having vinegar in your home. Add baking soda into the vinegar. So this is what is the reaction is. When you add vinegar and baking soda together, we get salt, water and carbon dioxide. So carbon dioxide is liberated. So to make it more funnier, you can add some colorant, some food color and soap with that. It you can see that carbon dioxide evolves with the foam. This is how maybe in your school, something like in your primary classes or something, you might have prepared an volcano, or some one of your friend might have prepared an volcano. This is how it is prepared. When baking soda and vinegar reacts, it forms salt and water, which will stays inside your beaker, bottle or whatever vessel you use, and carbon dioxide is liberated. If you add food colorant and soap, that soap along with the food, it shows like a nice fountain or a volcano which is evolving. So what is the chemical reaction which is taking place inside that? You can see that below that it has been mentioned clearly for you. Vinegar is nothing but acetic acid. It's a diluted form of acetic acid. About that in detail you will learn in next chapters. So acetic acid, CH3COOH, you might have come across this. When this acetic acid reacts with sodium bicarbonate, which is the chemical name of baking soda, together when they react, it is going to form sodium acetate, which is the salt which is formed. This is also in salt. Salt doesn't mean only sodium chloride. That's the table salt or common salt we use. Sodium acetate is one type of salt. Salt is a product of acid and a base reaction. So along with the salt, water is liberated and carbon dioxide gas is evolved. This is a simple chemical equation. So the word reaction which has been written on the top of this slide has been presented in equation form in the bottom. So representing a chemical reaction using their formulas is known as a chemical equation. Then the next thing is it balanced or unbalanced? In mathematics, you might have done LHS is equal to RHS. The same thing we also have to do in chemistry also. You should apply your mathematic knowledge here. So you can see here at the left side of my slide, you can see hydrogen and chlorine together is combining to give hydrogen chloride or hydrochloric acid. You can see, you know that hydrogen formula is H2. It doesn't exist singly. You know that in 9th standard you had studied about monoatomic molecule, diatomic molecule, triatomic molecule. So like that, hydrogen is a diatomic molecule as well as chlorine is a diatomic molecule. When these two combines, it forms HCl. So H2 and Cl2 is giving HCl. But you can see there are two hydrogen and two chlorine at the left hand side, and at right hand side only one hydrogen and one chlorine. I had just mentioned it down in the checkerboard. So reactants there are 2 2 and products there are only 1 1. So it means it's imbalance. You can see there it's showing imbalance. You might have played this game before. So similar to that I have shown you. So this. So next in the right hand side, observed in the right hand side, there by giving two hydrogen and two chlorine combining together, it is forming two molecules of hydrogen chloride, which is balanced now. Both side balance. This is how we have to balance a chemical equation. So where how exactly we have to balance, I will show you in the next in my next video on board. I will show you how exactly the numbers should be added and different methods. Okay, fine. So now let's take up one more equation which happens, this also takes place in your home. It's happening probably now inside the kitchen when your gas is on, the LPG cylinder containing methane, 95% will be methane in that. So that methane reacts with oxygen. You can see here the reactant side at the LHS, methane is reacting with oxygen to give carbon dioxide and water. Along with this, heat is liberated. We don't need carbon dioxide and water in this reaction in your home or in my home. We need heat, the heat which is used to cook the food. Carbon dioxide and water are liberated. So yeah, water, you might be amazed that where is the water liberated in your kitchen? No, that will be in the vaporized form. So it will get vaporized due to the heat produced. It will get vaporized, and carbon dioxide is a cleaner gas, so it doesn't show you any smoke there. Smoke is formed when there is carbon monoxide, when there is incomplete combustion takes place. Methane undergoes complete combustion, so it gives carbon dioxide. About that also we will learn it in carbonides compound chapter. Okay, at present you can see that this reaction can be represented in equation form, that is CH4 plus oxygen, that is O2. It gives rise to CO2 plus H2. It's balanced here. You can see that at left hand side if we write only oxygen, that is two oxygen molecule atoms are there, whereas here at the product side there are two oxygen atoms attached with carbon in carbon dioxide and one oxygen atom attached with H2 with in water, but there are three and here two are there, so to make it four, so we had multiplied H2O at the RHS and O2 at the LHS with 2. Now we have 4 oxygen in reactant and 4 oxygen in products. So this has been balanced. So if we go in the molecular level, this reaction looks like this. You can see here, these are the structures of atom. It's not exactly, it is the graphics which can be which will help you to understand this better. The carbon atom, you can see CH4 how it is. The carbon atom is bigger. You know that carbon has 6 protons, 6 electrons, 6 neutrons, so it is bigger, whereas hydrogen has only 1 proton, so hydrogen size is smaller. So you can see carbon is attached with 4 hydrogen at different corners, that combining with two molecules of oxygen. You can see oxygen molecule because two atoms of oxygen combined together in red color, which is shown here. So two molecules of oxygen is combining, and you can see there carbon attached with two oxygen atoms forming CO2 and water structure also you can see that. So if you go still deeper, so this is the way, this is represented with different number of atoms also. I have represented here reactants and products, both are mentioned. You can check out this slide. So the same reaction. I hope you got an idea about what is a chemical equation. So representing chemical reaction in form of their formulas. So in form of a mathematical representation using their formulas is called as a chemical equation. So that I showed you with 2-3 examples in the slides. I hope you got it. So further we have different types of chemical equations. So that we are going to discuss now. There is a small part balancing the equation. I need to go in depth. So today due to some challenges I couldn't do it. So I will do it tomorrow as I need a board, and you know that the country is locked down for 21 days. Maybe it may extend for still many days. So due to that, the availability of things outside is it's nil actually. So I'm trying to cover as much as possible without using that. Hope by tomorrow I will make something arrangement for you. So today let us continue with types of chemical equations. So different equation, different types are represented with different examples. We'll discuss in a short way, and that also in detail we'll discuss in the next video following, probably tomorrow. Fine. Okay, the first type of chemical reaction is combination reaction. It's a very simple reaction. So combination reaction is nothing but when two reactants combine together to give a single product. You can see here x plus y gives rise to xy. You can write it as a plus b gives rise to ab. So when two reactants are more than two also, no problem. Two or more reactants combine to give single product. The product should be single. Then it is called as combination reaction. It is simple combination, combining of multiple reactants to give a single product is known as a combination reaction. So it's simple, like we had gone through one reaction before in the slide. Hydrogen plus chlorine gives rise to hydrogen chloride. That's a combination reaction. There are two reactants were there and only one product. At a simplest, you can write C plus O2 gives rise to CO2. So when carbon reacts with oxygen, it gives carbon dioxide. So that is a combination reaction. And generally, combination reactions will be exothermic in nature. It means it liberates heat. Exothermic, exo means outside, therm means heat. So exothermic reactions are the reaction which gives out heat. So same like magnesium reacts with oxygen gives rise to magnesium oxide. A single product is formed and heat is liberated there. It might be heat, it might be light, it might be sound. So when energy is liberated out, it is called as exothermic reaction. So most of the combination reactions are exothermic in nature. The second type of reaction is decomposition reaction. It's the exact opposite of the previous reaction. Here, single reactant will give rise to multiple products. It might be two or more than two also. So here you can see in the picture, there is a single reactant. It's breaking down to give two products. So likewise, it happens in a reaction called as decomposition reaction. It required energy. It's opposite. I told you, like combination, it is the opposite of combination. In combination, during the reaction, heat is liberated out. In decomposition reaction, heat is consumed because a reactant should break down into two or more products. So for that, it needs energy. That energy is supplied in the form of either heat, light, or electricity. That we'll discuss in the following slides. So the third type of reaction is single displacement reaction. Displacement reaction in which there are two types, single displacement and double displacement. Single displacement, one element displaces the other element from a group. That is called as single displacement reaction. You can see the definition over there. The reaction where an element replaces the other element that is part of a compound. Products are a new compound and a different element. So you can see here in the reactants, there are two together, there is one group and there is one separate element. That element is displacing the other element in the group and forming a new compound. Such type of reaction is called as single displacement reaction. You can see AB plus C gives rise to AC plus B, or A plus BC gives rise to AC plus B. Here one condition is necessary. That condition is that the element which displaces the element should be more reactive than the previous element. Okay, if A has to displace B from BC, then A must be more reactive than B. then only A can displace B. If not, no. So same way in the right hand side example, AB plus C, here C is more reactive than B, then only it could displace B. If C was less reactive than B, it cannot displace B from AB. We'll see some example in the next slides. Then the fourth type of chemical reaction is double displacement reaction. So there is a little change from previous equation. So there one element had displaced another from a group. Here there are two groups, the two pairs. You can see AB is one pair, CD is one pair. What happens here is there will be exchange of ions, as AB is one group and CD is one group. So here both is going to be split out, and A combines with D and B combines with C, forms a new compounds AD and CB. So that is what is double displacement. Here very simple to remember. You should remember that there is exchange of ions taking place. Exchange, something like you have went to Big Bazaar and there is an exchange offer going on and you have exchanged it. That's it. That is called as a double displacement reaction. So you can see here in detail, there is in decomposition reaction, there are different types of decomposition reactions. So you can see here, this is photolysis. Photo decomposition, sorry, there is a mistake in the slide. Photo has been misprinted with thermal. It's not thermal decomposition, it is photolytic decomposition. It has mentioned in the beginning photolysis. This is photolytic decomposition, where the decomposition takes place in presence of light. You can see here in the right hand side in the image, there is silver chloride placed in china dish. Silver chloride is a compound which can undergo photolysis. Photolysis, photo means light, lysis means breakdown. So breakdown in presence of light, that is decomposition reaction. So what is happening here, you can see at the left hand in the equation, where AgCl in presence of sunlight, it is breaking down to give Ag and Cl. Silver and chlorine, it will break into silver and chlorine. That is photolytic decomposition. It's very important to even remember the colors which actually changes here. You know that the silver chloride usually will be white in color. What happens when the sunlight is passed to it, it changes its color to gray, because you know that silver is gray in color. So this is photolytic decomposition. So the next thing is, this shows the thermal decomposition. So thermal decomposition means decomposition reaction in presence of heat. For example, you can see here there is copper carbonate. Okay, CuCO3 has been heated in presence of it is heated. That's the only one reactant. It is heated by passing heat. You can see here it's giving rise to copper oxide and carbon dioxide. If you want equation, you can write down, that is CuCO3 gives rise to CuO plus CO2. So here there is single reactant in the first test tube. It has been subjected to heat, and then in the products you can see there is a copper oxide which has formed, which is black in color, and carbon dioxide is liberated. This is the example of thermal decomposition. Now the last one is electrolysis. Electrolysis means breaking down in presence of electricity. Electrolysis or electrolytic decomposition. So this is as a simple experiment. You can do it in your home. In our future videos, hope I will show you this when the things are available. I will show this. So here very simple. You can use a small battery. If you have a small battery of 9 volt, you can use a battery and connect that wires which are positive and negative terminals which are connected. The wires you can connect with two metallic strips, maybe two nails, iron nails you can use. You can even use your pencil graphite. You can use for both the wires. The one one metal strip which you connect with the negative end will act as cathode, and which connects with positive end acts as anode. So then if you dip it in water, so this is the proper setup which is shown here. Inside the beaker, two test tubes are placed and then that electrodes are dipped inside. If you don't have test tube, don't worry, take a glass. In the glass, you usually made up of glass, you take, don't take about metal, a glass, transparent one, you add water in that and dip the two nails which are connected to two ends of the battery. Wait for 2 to 3 minutes. What you can see is there are bubbles which you can see at present in the slide in the test tube. The bubbles are formed. So those bubbles are going to form on different metallic nails or graphite, whatever you have used. So you can observe on the positive end, that is on cathode, oxygen will get deposited. On the negative end, that is on anode, so sorry, that is on cathode, the hydrogen gas will be deposited. So this two gases which is collected from water, we are decomposing water. This is known as electrolysis of water. By passing electricity, we can break down water to hydrogen and oxygen. You can, if you are having test tubes, you can collect those gases also. Again, storing and all, it will be difficult, but you can observe that it is separated. And you can even observe one thing here is the gas which is collected at positive end will be double than the negative end, because you know that oxygen will be in double quantity than hydrogen. Okay, so here this is about electrolysis. Next, let's go for one more type of reaction. So this is the example for double displacement reaction. It is double displacement reaction. This is very important reaction. Many a times this reaction has been given for balancing. This example been asked in many different questions in CBSE papers. So you can see here, sodium sulfate reacts with barium chloride, is forming barium sulfate and sodium chloride. You can see the sulfate SO4 molecule of sodium sulfate is joining with barium to form barium sulfate, and chlorine from the barium chloride is joining with sodium to form sodium chloride. This is exchanging of ion or interchanging of atoms taking place in the reaction. This is known as double displacement reaction, and this reaction is also known as precipitation reaction. So in the beginning of this video, I had mentioned you precipitation. So this is an example of precipitation. What happens is the sodium sulfate and barium chloride both are liquids, both in aqueous form. I hope you know aqueous. Aqueous in the sense this sodium sulfate, which is solid, will be dissolved in water to form a solution. Like you add rasna powder into water to form that liquid rasna. So that is an aqueous solution. So same way, this sodium sulfate added in water, it's an aqueous solution of sodium sulfate, and barium chloride added in water will be an aqueous solution of barium chloride. When both the liquids are combined together, clear liquids are combined together, you can see that barium sulfate is formed and it is settled down at the bottom. It's a solid. Sodium chloride dissolves in water purely and it will form a clear solution, but barium sulfate forms a solid which you can separate also. Such reaction where a solid is formed on adding two clear liquids is known as precipitation reaction. So all precipitation reactions are generally double displacement. So this is one of the example of it. Then this is single displacement reaction. Hope you might have done it in your 8th standard when you are studying metals and non-metals chapter. Here you can see in blue copper sulfate solution, iron nail has been dipped. If you leave it for some time, few hours, one day, something, what happens, the color of the copper sulfate which was blue changes to green, because it's no more copper sulfate, it's an iron sulfate now, because iron from the nail has displaced the copper which was present in that solution and it formed copper iron sulfate. You can see in the equation below, Fe plus CuSO4 gives rise to Cu plus FeSO4, right? So this is a single displacement reaction. You can perform in your home also. Copper sulfate might be available in your home. The needy or ujala, what we call, which are used to add to the clothes for whitening. So this is that copper sulfate. So in that, if you place this iron nail, you can observe this change. This is the single displacement reaction. Fine, that's all for today. So we'll end up this video. Hope you enjoyed this. uh, Please like my video if the content was good. Subscribe to my channel if you want notification from tomorrow. Every day I will come up with different videos. I'm planning to cover this whole syllabus in your vacation, in this lockdown, probably, to use it productively. Hope you are also using your vacation, this lockdown period, for productively. Use it productively. Don't be negative in these days. Be positive. Learn something, as you are in 10th standard now. So the time is running. It's not under our control, as the whole country is locked down. Whatever is possible for us, we should try. So please use your time productively. And if you are having any doubts, any clarification, write it down in the comment section, or you can even reach it to my WhatsApp. Whatever you are having doubts, I'll clear you. And please give me feedback. I request you to give me feedback on my video if any changes I need to adopt, anything, as this is my first video on YouTube. So please give me suggestion, whatever I need to improve. Hope from the next time, however you need those things, I'll come up for you. Thank you everyone for watching. Bye bye.